Okay, now we've used G in the last, well, we introduced the idea of G in the last video, so let's move on with that. Now, a common misconception that goes on in society is that mass and weight are the same thing, or interchangeable at least. And so much so that if we have normal bathroom scales like the ones shown here, they will actually give the units of this as kilograms and then tell you, or pounds, and then tell you that this is your weight. And that's not quite right. So we need to think about what goes on with this. Effectively, what we're going to test you on is your understanding of this. And we're going to use this. Part of the calculation for using this, especially in work, involves us thinking about the effect of weight if we are looking at a vertical movement up or down. Now, we're going to make some assumptions, but more about that later. When they use, as it says here, people in general society talk about their weight and they talk about it in kilograms. Now, kilograms is not the unit of weight. Kilograms is the unit of mass, and we're going to distinguish between it, and I hope you will use the terms effectively and correctly from now on. Right, so science, we spend time going through differences. It's all about these things, the atoms. Alright, it's all about the atoms, so let's go and find out a bit more. Mass is about how many of these atoms you have. All atoms have mass. In other words, we can work out how many kilograms there are. Now, atoms being so tiny, obviously they're not going to have much mass for each single atom. But there are many cases we can think of that we find in everyday use or in the labs we're going to be using all year. There's not many times we're going to be having less than a few billion atoms. Even in something nice and small, as I've said here, there are millions of atoms found in something even small. So if you talk about a grain of sand or a piece of rice, we are talking about billions and billions of atoms. Now, all those atoms involved in that have mass. Now, if we have the single mass of one atom and then we have billions of them, then we multiply that value by billions and we start to get up into the area of grams, maybe even kilograms. And that's where it comes from. So kilograms and grams are going to be about a big pile of atoms. So when we talk about it, I want you to be mindful of that and use it correctly. Now, to distinguish, we should always use the units. Now, our units of mass are kilograms, the ones we are using. But sometimes in labs, you will measure grams and then have to convert it. Right, effectively what we've got here is the formula. Weight is a force, and it's the force that gravity exerts on the mass you have. So I'm sitting in the chair at the moment, and gravity is pulling at me, and if I work out the effect of that, I work out my weight. My mass is the total number of atoms that make up my body. That doesn't change unless I go slicing and dicing and doing things like that. Now, we can work out what our weight is by simply following the formula. And the formula tells us that force of weight, now little subscript W is weight, equals the mass in kg times gravity. Now, this is a constant. On Earth, it does not change. On other planets, it is different, but doesn't change. Now, on Earth, we're going to use this value. Now, we can also use that unit with it because that's the easiest one. So it's acceleration of an object due to gravity. And so this will allow us to calculate our weight. For example, what is the weight of a 40 kilogram student? Well, then we would have 40 times 9.8 and do the sums effectively. All right, so that's the difference. I would expect you now to know and be able to use those terms correctly and also understand the units as well.